Hello everyone, this is Lalitha, Assistant Professor, Electrical and Electronics Engineering Department. The today topic is Demultiplexer. In the last video, we upload the multiplexer. Kindly go through it. The demultiplexer is opposite to the multiplexer. The multiplexer is many to one, the demultiplexer is one to many. So these are under the combination logic circuits. In digital logic circuits, the combination logic circuits plays a major role. It can perform the arithmetic and logical operations. The combination logic circuits only the output is depends on the present input only. So that's why it can used for arithmetic and logical operations. So the multiplexer and demultiplexer plays a major role in the digital logic circuit. Now we go for the demultiplexer concept. The demultiplexer is simply called as an demux. A demux is a digital switch with a single input and a multiple outputs. The selection lines determine which output the input is connected. In the demultiplexer, the input is 1, the output is 2 power n, the n is a selection lines. So based on the selection line only, the input is connected to the output. The types of demultiplexers are 1:2, 1:4, 1:8 and 1:16. Because the output is 2 power n, so it is 2 power 0 means 2 power 1 is 2, so 1:2 multiplexer and 1 selection line. If it is 2 power 2, it is 1:4 demultiplexer, 2 selection lines. It's 2 power 3, then 1:8 demultiplexer, 3 selection lines. It's 2 power 4 and then 16 outputs, 4 selection lines. So these are the types 1:2, 1:4, 1:8 and 1:16 demultiplexers. Based on the output, the selection line will be fixed. The demultiplexer is a combinational circuit, we already explained, which receive one bit information and puts that information on the line which is selected by the binary input and the selection lines. This is different from decoder circuit, as there is also an information line and we do not have to put one every time on output as in decoder, but the bit which is present on information line. It is also generally called by demux. So these are the logical block diagram of 1:4 demux, 1:8 demux and 1:16 demux. In 1:4 demux, the input is 1, the output is y0, y1, y2, y3 and the selection line is 2 because 2 power 2, 4 outputs, so the selection line is 2, it's AB. Likewise in 1:8, the input is 1, the output is y0 to y7, 2 power 3, 8 outputs, so 3 selection lines. The selection line considered as an ABC or S0, S1, S2. Likewise for 1:16 demux, the input is 1, output is 16. It is denoted from y0, y1, y2 up to y15. The selection lines are 4, that is ABCD or S0, S1, S2, S3. The most medium scale integrated demux like the 3 shown have outputs that are inverted. This is done because it requires few logic gates to implement demux with inverted outputs rather than no inverted outputs. This is a typical application of a demux. The computer is connected with printer, fax machine, another printer and pen plotter. Once based on the selection line, the computer will be connected with these 4, it is any one of the 4 outputs. When the selection line is 0, 0, the computer is connected with the laser printer. When the selection line is 0, 1, the input of the computer is connected with the second fax machine. So the input is reflected in second output. When the input selection line is 1, 0, the computer is connected with color inkjet printer, that is the input is reflected in third output. When the selection line is 1, 1, the computer is connected with pen plotter, That is, the input is reflected in fourth output. So the demux is totally opposite to the multiplexer. The multiplexer is not multiply the value, it is the data selector. We already discussed. It is select the data based on the requirement. So based on the selection lines, the input is selected and reflected in the output. The one input is selected and reflected in output in multiplexer. In demultiplexer, it is opposite to the multiplexer. The one input is reflected in different outputs based on the selection line. So that's why the demultiplexer is called as an data distributor. The multiplexer is called as an data selector. The demultiplexer is called as an data distributor. Now we go for a 1:2 demultiplexer. The demux has two output channels and one control signal. When the control signal, that is selection line, is 0, the first output channel is selected. When the control signal is 1, the second output channel is selected as a route for input data. There is also an enable bit used for enabling or disabling the circuit. It can be active high or active low. Here we have the block diagram of 1:2 demux. The input is 1, that is D, and we have the enable input E, and the selection lines is 1, that is S. The output is 2 because it's 1:2. So 2 output is Y0, Y1. When the input D is 0, the input is reflected in first output. When the selection line is 1, the input is reflected in second output. That is the concept of the demultiplexer. Next we go for 1:4 demux. It consists of one input, 4 outputs and 2 control lines to make the selections. The input bit is data X with 2 selection lines A and B. The inputs are D0, D1, D2 and D3. When the selection line is 0, 0, the input is reflected in first output. When the selection line is 0, 1, the input is reflected in second output. When the input is 1, 0, when the selection line is 1, 0, the input is reflected in third output. When the selection line is 1, 1, the input is reflected in fourth output. That is the concept of 1:4 demux. Here the block diagram, truth table and the logic diagram of 1:4 demux. In the demux, the input is X, output is D0 to D3, the selection lines are A, B. Here we have already discussed, when the AB is 0, 0, D0 is 1. When it is 1, 0, the D1 is 1. When it is 0, 1, the D2 is 1. When it is 1, 1, the D3, the input is reflected in D3, so that is 1. Otherwise we have the enable button also. So for this truth table we can make the logic diagram using NOT gate and AND gate. Likewise we can design the 1:16 demux, 1:8 demux. Likewise we have the waveforms for the, now we can show the waveform of 1:4 demultiplexer. The first one is input X, the second and third waveform is selection line waveform. The D0, D1, D2, D3 is output waveform. The block diagram of a 1:8 demultiplexer consists of one input D, 3 selection lines S0, S1, S2 and the 8 outputs Y0 to Y7. It is also called as 3 to 8 demultiplexer due to 3 selection lines. It distributes one input line to one of 8 output lines depending on the combination of selection inputs. That's why we already told the demultiplexer is called as an data distributor. Here we have the truth table and Boolean expression for 1:8 demux. We have the data input D, the selection line S0, S1, S2. So we have, if it 3 inputs means we have the 8 combination, that is 0, 0, 0 to 1, 1, 1. When the input selection line is first selection line, the input 1, the input is reflected in first output. When the selection line is 1, 1, 1, the input is reflected in last output. So the expression for this output is y0 equal to d s0 bar s1 bar s2 bar. For y1 d s0 s1 bar s2 bar. For y7 d s0 s1 s2. So likewise we can design for 1:16 demultiplexer. This is the logic diagram is 1:8. Draw the logic diagram using NOT gate and AND gate. It is a 4 input AND gate. The first AND gate is connected with D, S2 bar, S1 bar and S0 bar. The last AND gate is connected with D, S0, S1, S2. Here we have the implementation of higher order demultiplexer. Implement 1:8 demux using 1:2 and 1:4 demux. We require two 1:4 demux in second stage in order to get the final 8 outputs, since the number of inputs in second stage is 2. We require 1:2 demux in first stage so that the outputs of first stage will be the inputs of second stage. The input of the 1:2 demux will be the overall input of 1:8 demux. So this is the implementation of 1:8 multiplex using 1:2 and 1:4. The output of the 1:2 is given to the input of the 1:4. Then the final output will be y0 to y7. Totally it can consider the 1:8 mux, 1:8 demux, single input and 8 output. We have the 3 selection line. The one selection line is used in 1:2. The another 2 selection lines are used for 1:4. Next, implement 1:16 demux using 1:8 demux and 1:2 demux. We require two 1:8 demux in second stage in order to get the final 16 outputs. Since the number of inputs in second stage is 2, we require 1:2 demux in first stage so that the output of first stage will be the input of second stage. The input of this 1:2 demux will be the overall input of 1:16 demux. Here we have the diagram of 1:16. The input is 1, the output is y0 to y15. We have 4 selection line, 1 selection line for 1:2, another 3 selection line used for 1:8. The third one is implement the full subtractor using demux. The full subtractor difference minterms are 1, 2, 4, 7. The borrow minterms are 1, 2, 3, 7. So likewise we can draw the subtractor using demux. We can use 1 input, 3 selection line and 8 outputs y0 to y7. Using OR gate we can draw the multiplexer, implement the multiplexer using demux. Likewise we can design any combinational logic circuit using demux. Thank you.